All right, so in this video, we're going to continue looking at 2, but I'll be working with just trying to graph a piecewise function. Okay, so this might scare you if you haven't done graphing, but don't go run drop the class. You don't, you can pick this up after you do some homework. All right, so when you're given a piecewise function, there's more than one rule being used for different portions of the coordinate plane. Okay, there's more than one rule, and you use a particular rule in a particular area. So what I like to do when I'm graphing something like number 7 is I like to look at these conditions first, okay? And do you notice that we have a rule that you use when you're less than or equal to -1, and then a rule that you use when you're greater than -1? So this is not an asymptote, but what I'm going to think about is breaking up this coordinate plane so that when I'm bigger than -1, I use the rule, and I'm going to think about f of x as being like a y. Then I'm going to use y equals x minus 2. But if I'm less than -1, I'm going to use y equals just 3, because it tells me to. Okay? When I'm right at -1, because of the or equal to, I'm going to use the top rule. So what works well is to graph the equation and just use one of those XY tables. So when I'm less than -1 and I'm trying to graph y equals 3, what you want to think about is how y equals 3 is just a horizontal line, or you could plug in values like something to the left, like -4. If I were less than -1, I would use that rule, and that rule says my output is 3. When I'm at -2, that rule says my output is 3. And then I want to also find out what happens right at the boundary, even though that's not, that I didn't say right there that I was going to allow it to be equal to -1. So you still like to check that boundary. Okay, so at -1, I would still get a 3 if I were using that rule. Okay, so when I'm graphing that part then, well, this is -1, -2, -3, -4, 3. -2 would be 3. And when I'm at -1, I'd be at 3. So on this portion of the graph, I'm going to have this horizontal line, okay, that would keep going. But then as I come towards the -1, I have to decide whether to think about it as being open or closed. So I go back to that condition and find out when I'm at -1, I'm supposed to be using that top rule. So I'm going to put a closed dot on that end. Okay. Now I'm going to go to what I use when x is bigger than -1, which is this equation. And when you're graphing that, an XY table works really well, but if you also already know how to graph lines by using the slope and the y-intercept, feel free to do that. Okay, so let me graph this one in a different color. All right, so what I could do is focus on that region I'm trying to graph, which is numbers that are bigger than -1, but it works well to consider that endpoint anyway, so make sure you include the -1, then you might do a 0, then you might do like, a 3 or something like that. So when x is -1, -1 minus 2, that would give me -3. When x is 0, 0 minus 2 would give me -2. When x is 3, 3 minus 2 would give me 1. Okay. You could have picked any x values you wanted. You didn't have to use the same ones I did. I just recommend that you do that endpoint, okay, so that you can get a nice picture. Okay. So with this one, the ordered pair 3, 1 is a point that's on the graph. The ordered pair 0, -2 would be on the graph. And then if I were allowed to use the rule for -1, I'd be down here at -3. Okay, so now I got to think about how that rule is going to be not going to be used when I'm at -1. So put an open circle there, because you can only have one spot, okay, one value for each x. So when x is -1, the value should be 3, not -3. So use an open circle, and then this should be linear. So after you get a few points, you can just connect them with a line. So there you have it. Okay? So break up your coordinate plane into pieces. So if there's 2 rules, it'll be 2 pieces. And then graph the rule in each piece, but your function is still just one function. It just is composed of 2 pieces. Okay, so that picture altogether is the graph of that function, and it just has 2 different pieces to it. Now, one of the things you're sometimes asked to do is graph and then determine the range. So we'll be doing that on the bottom one. Thought I would do it here. Looking at this, if they don't ask you for domain because it's not very interesting typically. The domain, if you look at the possible x values of all the ordered pairs, it's from -infinity to +infinity. But with the range, you get all sorts of interesting things. Okay, so like if I'm looking for the range, the lowest point I ever get to is here, and it's an open circle. So that y value of -3 would not be included. And then the highest point, there isn't a highest point because that keeps going. So the range would be from -3 to infinity. When you're thinking about this and you're trying to do range, you got to think about how, yeah, these right here all have a y value of 3. If I smushed these to the y-axis, okay, what would be covered up? Oops, didn't smush that one right. What would be covered up would be all the values from -3, and then see how I would go past 3 and keep going, and it would just have an open circle there. So from -3 to infinity. So you're going to be asked to do range a lot of times on these because it can be kind of interesting when you see what happens. All right. Now, when you're asked to graph, these should be things that you could graph by just using some ordered pairs, and they probably are going to just involve either lines or possibly parabolas, but they can't do much other than that. Okay. All right. So here's one that has 2 rules. One of them I use when I'm bigger than 1, greater than 1. One of them is used when I'm less than or equal to 1. And 1 is right here. So I'm going to cut my coordinate plane right there. Okay, that is not an asymptote. It's just me separating my coordinate plane into 2 pieces. When I'm greater than 1, I use the rule y equals 2x plus 1. I'm following this. This is my y. I'm following the bottom rule. Okay, when x is less than 1, then I'm going to use the top rule. Y equals -1/2 x squared. When I'm right at 1, I'm going to use the top rule on that one. So that's where the closed versus open circle comes into play. All right, so let's get busy. So y equals 2x plus 1, if I'm trying to graph that. Remember, that's what I'm using when x is bigger than 1. So that's, if x is bigger than 1, use that rule. So even though it says bigger than 1, and even though it doesn't have an or equal to on it, it's good to check that endpoint. Then pick a few other values that are bigger than 1, like 2, maybe 3, something like that. So if I plug in a 1, I'm going to get 2 times 1 plus 1. 2 plus 1 is 3. If I plug in a 2 to that rule, oops, it's not plus 2, it's plus 1, I get 4 plus 1, which is 5. If I plug in a 3, 2 times 3 plus 1 would be 6 plus 1 would be 7. Okay. Now again, if you know how to graph lines using slope and y-intercepts, feel free to do so. But the xy table works good since you're not always going to be using the rule on the y-axis. So that's why I like to just plot points. All right, so then let me plot that. So 1, 3 would be there. Okay, 2, 5 would be here. 3, 7 I can't really show. It would be up here. but it shows me the gist of where my line would be. So I know this is my graph. It's going to do that, right? It would keep going. I'm just going to put an arrow on it. And then I'm not supposed to use that rule for my y value, so I'm going to put an open circle and make that clearer. Okay. I want that to be an open circle because I'm not supposed to use that graph. Okay, so that's that piece. Now, if x is less than 1, I'm supposed to use y equals -1/2 x squared. Okay, meant to be doing that in green. Less than 1. So still find out what happens at 1, maybe at 0, maybe at -2, something like that. Okay, this should be U-shaped. This is a parabola, okay? And so it should turn out to be like a U, okay? All right, so plug in a 1. Make sure you square the 1 first and get 1, and then multiply by -1/2. Okay? Let me plug in a 0. 0 squared is 0 times -1/2 would still be 0. Plug in a -2. And this one, make sure the -2's in parentheses. And you're thinking -2 times itself, which would be 4, and then +4, and then -1/2 times +4 would be -2. Okay, so when I go to plot those, I know 0, 0 is there. I know -2 is there. Okay, and then I have 1, -1/2. So it'd be about right there. Okay. All right, now, if you don't have much experience with that, you might think you did something wrong. But this is a negative with a squared. It's going to be a parabola that opens down. If you're not as familiar with it, you might just plot more points. So like if I put in a -1 and squared it, that would be +1 times -1/2. I'm over here at -1, I'm also going to be at -1/2. So there's that U of my parabola, and it curves right there and hits at that spot. And this one did say that I should use that rule, so I'm going to put a closed dot right there. So this one has an interesting range. The domain would be all reals if I were asked to do that. But for the range, you know, for a lowest point, doesn't it keep going, okay, down? So that would be -infinity. But as I move up, I'm going to need a little more room for this. Move that over just a smidgen. All right, so for the range, the lowest, there is no lowest. This keeps going, so that would be -infinity. And then as I look at this, there's a gap. See that gap right here? Okay. So you're thinking about what the y coordinates would be. So you're imagining projecting these points onto the y-axis. So wouldn't it be, all of these would be covered up. This would keep going. And I would even go past there, because wouldn't that point have a y coordinate at 0? But then there's a gap, okay, for a little ways. And then it picks up again, and these points, okay, would mean open circle there, and it would keep going. Okay, so your range would be from -infinity, and you wouldn't stop at -1/2. You'd go all the way to the 0 that I had. This point right here has this point. Let me make sure you see it. I'll do it in purple. This point right here, okay, right there, has a y coordinate of 0. Okay. Then you're going to pick up, and you're going to pick up at an x of 3 and keep going because of the arrow on that. So -infinity to 0, okay, you kind of assume or you know that point's included, so you would do a bracket. But you see how the 3 has an open circle, so I would use a parenthesis on that. And then technically that should be a union in between. So you have 2 distinct intervals, really, on this one. All right, let's try graphing another one. Okay. All right, so this one's asking me to graph something with 2 rules again. One of them when I'm less than -3. So if I'm less than -3, I'm going to use the rule y equals x plus 2. And when I'm bigger than -3, I'm going to use the rule y equals x minus 2. And that's the one that has the or equal to on it. So right here at -3, I would look at whatever I get when I plug it into y equals x minus 2. Okay? So what works well is to be thinking, if x is less than -3, use y equal x plus 2. And then if x is bigger than or equal to -3, you're supposed to use y equals x minus 2. Okay? So make your little XY table. Consider where you're using it. When you're to the left of -3, put a couple values in. You know it's a line, so you don't have to do very many. But I might do like a -5, maybe a -4, but also include the boundary, even though it doesn't have an or equal to on it. So you know what that value would be. So when you plug in the -5 and add 2, you get -3. When you plug in the -4 and add 2, you get -2, and then -3 plus 2 would be -1. So plot those. -5 would be, -5, -3 would be there. -4, -2 would be here. And then -3, -1 would be there, but I'm not supposed to use that rule for that one, so I'm going to do an open circle. Let me erase my dot so I can clearly show that. An open circle. But see, I needed to go all the way to there because of these points. Right? I can get really close to that. I just can't be right there. Okay? So that's the picture for that portion of the piecewise function. All right, now I'm going to do a similar thing over here. I'm using y equals x minus 2, and my x values that I'm going to use are going to be bigger than -3. So maybe a -3, maybe a 0, maybe a 2. You don't need to use very many because you should recognize both of these as being lines. Okay, so -3 take away 2 would be -5. 0 take away 2 would be -2. 2 take away 2 would be 0. So 2, 0, 0, -2, and then -3, -5, 2, 3, 4, 5 would be down here. And when I am at -3, I use the second rule, so that's the blue one. So I'm going to make that a closed dot. And then I'm going to connect those points and put an arrow indicating that would go on forever. Okay. Now when you do the range, you're doing the overall range for the piecewise function, which is both parts kind of together. So you really just are thinking about all the possible y values. So don't forget that this side right here keeps going. You might not see that it goes past this dot right here, okay? But it does. Do you see that? So you'd have a y value as, you could get a y value as small as you want it to be because there's no lowest point. It keeps going towards -infinity. And then it really doesn't stop. You know, there's no gap here because if you imagine those being painted and then you consider what the y coordinates are, wouldn't those be the y coordinates for the green portion? Would be all of this. Okay. And then the y coordinates for the blue portion, if I consider what they would be, it would also cover up those, but then it would keep going because these could be projected to the y-axis, and then doesn't that arrow mean it would go on forever? So looking at that one, you kind of have a unique situation where it's really just -infinity to +infinity. They kind of overlap vertically so that your range is actually all real numbers.